Hey guys, welcome to this session by Intellipaat. Now you guys would have used a lot of virtual assistants such as Siri, Cortana and Alexa. And these virtual assistants really do make our task very easy, don't they? So let's say if you ask Siri, what is the distance between Earth and the Sun? It'll immediately reply the distance is 149.6 million kilometers. And similarly, if you ask Siri what is I'm hungry in Hindi, it'll reply मैं भूखा हूँ. Now, Siri or any other virtual assistant, how is it able to do this? Well, all of this is possible because of natural language processing. So keeping in mind how important NLP is, we've come up with a tutorial on natural language processing. So let's have a quick glance at the agenda. We'll start off by understanding what exactly NLP is, and then we'll learn how to tokenize words with the NLTK package. After that, we'll learn some concepts of NLP such as stemming, lemmatization, POS tagging, and named entity recognition. And going ahead, we'll also implement some of these NLP concepts with the Spacy package. And finally, there'll be a quiz to recollect whatever we've learned in today's session. So let me start off by asking a very simple question. What do you understand by the term natural language? Well, simply put, natural language is any language which has evolved naturally in humans. So any of these languages, English, Hindi, French, Telugu, or any of the numerous languages which has evolved naturally in humans through use and repetition without conscious planning can be termed as natural language. Now, since we're humans, we're able to comprehend these languages. But what about a machine? What if these same languages are fed to a machine? Will it be able to comprehend them? So this is where natural language processing comes in. So natural language processing is the ability of a computer program to understand and interpret human language as it is spoken. Or in other words, NLP is used to gain knowledge from the raw textual data at our disposal. Now let's go ahead and look at the components of NLP. So NLP can be basically divided into natural language understanding and natural language generation. So let's start with natural language understanding. So NLU, as the name states, deals with understanding the input given in the form of sentences in text or speech format. And this is where the machine analyzes the different aspects of language. Then we have natural language generation. So NLG deals with turning raw data into simple human understandable language, or in other words, producing natural language from raw input. Now to implement the NLP concepts, you would need some packages tailor-made for natural language processing. So in today's session, we will work with two such packages which are NLTK and Spacy. So generally the first step in NLP process is tokenization. So in tokenization, we basically split up our text into individual units, and each individual unit should have a value associated with it. So let's take this example. We have a sentence, Joey doesn't share pizza, and we are splitting this up into individual tokens where each word is taken as a separate token, and also the exclamation marks are taken as separate tokens. Now we can use these tokens for another process like parsing or text mining. So let's actually head on to a Jupyter notebook and learn how to tokenize a sentence using the NLTK package. So we'll start off by importing NLTK and NLTK.corpus. I'll run this. After that, we would require the word underscore tokenize function from the NLTK.tokenize package. So we'll also import this function from NLTK.tokenize. I'll click on run. So over here we have a string. So after surprising the host in the first test, Sri Lanka made a positive start to the second test. So this is the entire string over here, and I am storing it in an object named as cricket. Now what I'll do is, I will pass in this object inside the word tokenize function, and I will store the result in cricket underscore tokens, and I will print this out. So this is the part where we are basically tokenizing this entire string into individual tokens with the help of this word underscore tokenize functions. So I'll click on run. Right. So we see that this entire string is split up into individual tokens. After is one token. Surprising is token. The is token. Host is token. So again, we've taken up this entire string and split this up into individual tokens. Now, after doing that, let's also have a glance at the type of this and the number of tokens we have. I'll click on run. So see that this is a list of all the tokens and we have 201 tokens in total. Now let's also get the frequency of these tokens. That is, I want to find out the number of times each token value occurs. And for that, I would require the frequency dist from NLTK.probability package. So I'll import this and I will create an instance of this with the name fdist. Again, I'll click on run. Now I will create a for loop where this I value will iterate through all of the tokens, and for each token I will keep on adding the count wherever it is encountered. And finally I will print this out, which is fdist. So I get the frequency of all the tokens over here. So see that the occurs 11 times, comma occurs 8 times, A occurs 6 times, for occurs 6 times, South and Africa occur 5 times, right? So this basically is the frequency distribution of all the tokens. Now if I want to find out the 10 most common tokens, then I have this most common function. So I'll call fdist.mostcommon and I'll pass in the parameter which is 10. So this will give me the 10 most common tokens and I'll store it in top 10 and I'll print it out. I click on run. So these are the 10 most common tokens. So the is the most occurring token which occurs 11 times. Now human beings can understand linguistic structures and their meanings easily, but machines are not successful enough on natural language comprehension yet. So when a machine has to parse through one word at a time, it may not be able to fully understand semantics of a sentence. And these words, when given one at a time, are known as Uni-grams. So let's take this language over here. I love natural language. And when each of these tokens are given one at a time to the machine, this is nothing but a Uni-gram. I love natural language. So these are basically Uni-grams given to the machine. And similarly, when the machine is given two words at a time, it is known as a bigram. So this is a bigram. I love natural language. So this entire sentence is basically being given in the form of two tokens at a time. And similarly, when this entire sentence is given three words at a time, it is known as a trigram. So this time it is split like this. I love natural is one part and then we have love natural language, right? So this is the trigram which we have over here. So again, let's head back to Jupyter Studio and learn how to create bigrams and trigrams. So over here we have this sentence. Did you know there was a tower where they look out to the land to see people quickly passing by? And I stored this in black smoke. So I'll just quickly hit on run. And now I will tokenize this sentence with the help of the word tokenize function, and I will store this result in black smoke token and then I'll print it out. I'll click run. So these are the individual tokens from this entire sentence which we have over here. Now if I want to create bigrams and trigrams from this, we have the NLTK.bigrams and NLTK.trigrams function. So I will use this NLTK.bigrams function and then pass in these individual tokens inside this function, right? So I am passing this black smoke token object inside the NLTK.bigrams function and I want to see the result in the form of a list. So I click on run, right? So now these individual tokens are being represented in the form of bigrams. Did you know there was. Similarly, if I want to represent these tokens in the form of trigrams, I will use the NLTK.trigrams function and then pass in this object which is black smoke token. Again, I'll hit on run. Now we have trigrams. Did you know there was, right? And finally, we have something known as n-grams. So n-grams basically has an additional parameter over here. So if I want 4 words together, I'll put in 4. If I want 5 words together, I'll put in 5. Similarly, if I want 10 words together, I'll just put in 10 over here. So for that, I'll have to use the NLTK.ngrams function. And the first parameter inside that would be the list of tokens. After that, the parameter which would tell us the number of words together. And this time I want to see 4 words together. I'll put in 4 and then I'll click on run. Right, so over here we have 4 words together. So now let's understand stemming. So stemming is the process of reducing a word to its base form. And this is done by cutting off the beginning or ending of the word. So this indiscriminate cutting will be successful in some occasions and fail in other. So let's take these three examples over here. So this first case, studies, we have cut off the suffix es and it becomes study. And the second case, giving, we have cut off ing and it becomes giv. And in the third case, we have cut off ing from buying and it becomes buy. So in all of the three cases, we see that only in the third case, we have a word which makes sense. So when we are implementing stemming, it is always not necessary that the final stemmed word which we get should have a meaning associated with it. Now there are many stemming algorithms available. So one such stemming algorithm is Porter-Stemmer, and we'll be importing this Porter-Stemmer from NLTK.stem package. After that, I will create an instance of this Porter-Stemmer with the name PST. I want to stem these three words over here: winning, studies, and buying. So I will pass in these three words inside pst.stem. So pst is the Porter-Stemmer instance, and this instance basically has the stem function. So I want to stem the word winning, the word studies, and the word buying. I'll hit on enter. So I just have to run this first. Now I'll click on run again. Alright. So you see that winning has been stemmed to win, studies has been stemmed to study, and buying has been stemmed to buy. Now, similar to stemming, we also have lemmatization. So lemmatization is the process of reducing words into their lemma or dictionary. So the base form into which the word is converted should definitely have a meaning associated with it. So again, we have three cases over here. Studies is converted to study, which obviously has a meaning. Giving has been converted to give. Similarly, buying has been converted to buy. So see that these three individual base words have meaning associated with them. Now to implement lemmatization with the help of NLTK package, we would need the WordNet and WordNet Lemmatizer. So we will be implementing these two from NLTK.stem packages. And I will create an instance of this WordNet Lemmatizer. Now what I want is, I want the lemma forms of these three words: cats, cacti, and geese, and I will store this in this object words to stem. So after that, I will basically create a for loop which will go through these three words and lemmatize each of them. I'll hit on run. Right, so you see that cats has been lemmatized to cat, the lemmatized version of cacti is cactus, and finally the lemmatized version of geese is goose. Now, another important concept of natural language processing is parts of speech tagging. So in the English language, words can be considered as the smallest elements that have distinctive meanings, and based on their use and functions, words are categorized into different classes which are known as parts of speech. So POS tagging is the process of marking or tagging every word in a sentence to its corresponding part of speech. So let's take this sentence: Joey loves pizza. Now we can mark each of this word with a POS tag. So the word Joey is a noun, loves is a verb, and similarly pizza is a noun again. So we'll be adding POS tags to this sentence over here. What do you mean I don't believe in God? I talk to him every day. And I've stored this in this object peace. Now again, first task would be to tokenize this sentence. So I will use the word underscore tokenize function and pass in this object, and I'll store the result in peace tokenize. So let me execute these two. Now I will start a for loop which will iterate through all of the tokens, and for each of the token I will add a POS tag with the help of this POS tag function. So I will use this NLTK.POS tag and add a POS tag to each of the individual tokens from this piece tokenize list. I'll click on run. Right. So you see that each of these individual tokens has been marked with a POS tag. So what has a POS tag of WH pronoun, do has a POS tag of verb, you has a POS tag of personal pronoun, and mean has a POS tag of noun, right? And similarly, we have these POS tags for the rest of the tokens. Now, let's also add POS tags for another sentence over here. So this sentence is, Mary had a little lamb whom she really loved. And we are storing this in the object Mary. Now again I'll use the word underscore tokenize function and pass in this object, and I'll store the result in Mary underscore tokenize. After that I'll use this for loop which will iterate through all of the tokens and add a POS tag to each of the tokens. I'll hit run, right? So Mary is a proper noun, had is a verb, a is a determiner, and similarly we have other POS tags associated with each of the words. Moving ahead, we'll understand what is named entity recognition. So named entity recognition is the process of taking a string of text as input and identifying relevant nouns such as people, places, and organizations that are mentioned in that string. So in the sentence, Apple buys UK startup for $1 billion. Apple has been recognized as an organization. UK has been recognized as a geopolitical entity, and $1 billion has been recognized as money. Now, one thing to be noted over here is all these three words are nouns. So named entity recognition is done only on nouns. And to do named entity recognition, we would require this any underscore chunk function. So we'll import this from the NLTK package. I'll hit on run, and we would want the named entity recognition for this sentence over here. John lives in New York. I'll store this in John. Again, the first task is to tokenize this sentence. So I'll use the word underscore tokenize function and pass in this object John inside this. I'll store it in John underscore token. I'll click on run. Right, so we have tokenized this. After that, we will add a POS tag with respect to each of these tokens. So I'll use the function NLTK.POS tag and pass in these tokens, and I will store this in John tags, and I'll print this out. Right, so we have a POS tag associated with each of these tokens. John is a noun, lives is a verb, N is a conjunction, right? Now finally, it's time to get the named entity recognition of these POS tags. So I will use the any underscore chunk function and pass in this John underscore tags object inside it, and I'll store it in John underscore ner. After that, I'll print it out. Right, so see that John has been recognized as a person. Similarly, New York has been recognized as a geopolitical entity. Again, the thing to be kept in mind is the named entity recognition is done only on nouns. John is a noun, New York is a noun, right? So that is why John has been recognized as a person and New York has been recognized as a geopolitical entity. So all of those tasks were done with NLTK. Now we also have Spacy, which is a relatively new framework in the Python natural language processing environment, but it will quickly gain ground and will most likely become the de facto library for natural language processing. So Spacy is written in Python language, that is C extension of Python, which gives C-like performance to the Python program. So let's go ahead and import the Spacy package. Now the Spacy package has different models. So we'll load the EN core web small model and store it in NLP object. I'll hit on run. Right, now using this NLP object, I can create different documents. So these documents basically contain strings. So each string can be classified as a document. So I will store this is Pata inside this document. I'll click run. Now, so tokenization is very simple when it comes to a Spacy package. So all I have to do is start a for loop and print all of the tokens present in that document. So for token in doc, so it will iterate through all of the tokens present in the doc and print the text of all of the tokens. I'll hit run. Right, so these are the 5 tokens which are present in the string. This is Sparta, and then we have 2 exclamation marks. Now after that, let's see if I want to get the third token from this. So if I want to get the third token, then that is present at index number 2 of this document. So 0, 1, 2. So that is why I'll pass in doc and I will give in the index number which is 2, and I'll store this in token. Right? So the third token is Sparta. Similarly, if I want all the tokens present at second, third and fourth indexes, so I can use this. So inside the parenthesis of doc, I will start at 2 and I'll end at 5. So this will basically give me all the tokens starting at second index and ending at the fourth index. Now let me go ahead and print the token index and the token text together. So this is a document, this is Sparta. Now in this print command, I am first printing the token index, which I get with the help of token.I. After that, I am also printing the tokens text, which I get with the help of token.text, right? So I have the token index and I have the corresponding token text to each of these index values. Now similarly, let me also do POS tagging with the Spacy package. So for that, the document is Joey doesn't share pizza, and I will iterate through all of the tokens in this document. First, I will print in the index of the token. After that, I will print in the text of the token, and finally I will print the POS tag of these tokens, right? So we have the index value, we have the token text, and we also have the POS tag corresponding to each of these tokens. Now similarly, we can also do named entity recognition. So for this, we have the string Apple is looking to buy UK startup for $1 billion. And obviously I've stored it in this doc object. I'll click on run. And over here we have this for loop for ent in doc.ents will print out the entity's text and also the corresponding entity label. So basically doc.ents comprise of all the entities and the corresponding labels with respect to the entities recognized. So I'll hit on run. Right. So this doc.ents has recognized these three entities. Apple has been recognized as an organization, UK has been recognized as a geopolitical entity, and $1 billion has been recognized as money. Barack Obama, the former president of United States, will be vacating White House today. I'll click on run. Again, I'll start the for loop and I will print the entity and the corresponding entity recognition. Right, so Barack Obama is recognized as a person, United States is recognized as GPE, and today has been recognized as day. And finally, we have also something known as matcher from Spacy. So this matcher helps us to find patterns in a string with different criteria, such as understanding the lemma of the word, understanding if the word is a digit or not, understanding if the word is a punctuation mark or not, so something like that. So let's do some pattern matching on the string over here. Barack Obama, the former president of United States, will be vacating White House today. Again, I will store this in doc. So now, first I will create a pattern. So pattern is basically created as a list of dictionaries. So each dictionary indicates a word. So the first word we are basically trying to match with the lemma value. So the first word's lemma should be vacate. And after that, it needs to be followed by another word which is white, right? So I want to extract a substring from this entire doc, which is basically two words. The first word is a lemma variation of vacate and the second word is white. Now I will create an instance of matcher by passing in NLP.vocab inside this. Now this matcher instance has this add function which basically takes in three parameters. First parameter is the ID, which helps us to uniquely identify this pattern matching. After that, the second parameter is basically the callback function, which I've stated as none over here. And the third parameter is the pattern which I want to identify from the string. So I've given these three parameters. After that, I will pass in the document inside the matcher function and I will store it in matches. I'll hit run. Now, this matches object will basically comprise of three things: match ID, start index, and the end index. And I will put these three inside the for loop and get the substring from this document. So I'll hit on run. Right. So I have successfully extracted vacating white from this entire string over here. So the pattern basically was the first word needs to be a lemma variation of vacate and it needs to be followed up with the word white. Now similarly, let's also do pattern matching on this string over here. 2018 FIFA World Cup, France won. I'll click run. So this time the pattern matching should be something like this. The first word should be a digit, second word should be FIFA, third word should be world, and the fourth word should be cup. Again, I will create an instance of this matcher and I'll pass NLP.vocab inside this. After that, I will use the add function and give these three parameters. So ID is FIFA pattern, second parameter is none, and the third parameter is basically the pattern which I want to extract from the string. And after that, I will use this match2 and pass in this document inside this and store the result in matches2. I'll click run. So again, I'll use this for loop and extract the substring from this original string. I'll click on run, and I have successfully extracted the substring, which is 2018 FIFA World Cup, from this original string over here. Right, so this is how we can implement NLP concepts with the help of NLTK package and Spacy package.
So now we'll see how to do sentiment analysis using the NLTK package. So we'll start off by loading all of the required packages. I'll import NLTK, I'll import random, and we'll also be doing a bit of classification. So for that purpose, we would require all of these classifiers. So we'll need sklearn classifier, we'll be implementing the naive-based classifier, SGD classifier, logistic regression, and SVC. So I'll be importing all of these. So I'm importing multinomial NB, Bernoulli NB from sklearn.naive-base, and I'll also import logistic regression and SGD classifier from sklearn.linear model. And also we'll be implementing the support vector classifier. So I'll be importing SVC, linear SVC, and NUSVC from sklearn.svm, right? And we would also have to do a bit of pre-processing of the data which we have. So for that purpose, we would import the word tokenize from nltk.tokenize. And to load the file, we would require the OS package. So I'll also import that. I'll click on run. So we have imported all of the packages that we need. Right, now it's time to load our dataset. So we'll be performing sentiment analysis on top of the IMDb reviews dataset. So this basically consists of 25,000 reviews, and out of these 25,000 reviews, 12,500 are positive reviews and the rest 12,500 reviews are negative reviews. So these two are stored in separate folder. So there is one folder called as POS, and it would contain all of the positive reviews, and there is another folder called as NEG, and it would contain all of the negative reviews. Right. So first I will load all of the positive reviews into files underscore POS. So these are the two lines over here. So what I'm doing is I am reading every single review as a single line. So for F in files underscore POS, what I'm doing is, so for every positive review, I'll read it and I'll store it into files underscore POS, right? So files underscore POS would have all of the positive reviews. And similarly, I'll do the same thing. So all of my negative reviews are stored in this NEG folder. So this is the entire path is of D drive, and the folder which has the negative reviews is NEG, and I will keep reading every single review and I'll store it in files underscore NEG. I'll click on run. So this is a huge dataset which comprises of a lot of files. So now I have my positive reviews and my negative reviews. Let me find out the length of both of these. So as I told you guys, there are 12,500 positive reviews which are stored in files underscore POS, and similarly there are 12,500 negative reviews which are stored in files underscore NEG. Right. So now we have our positive reviews and negative reviews with us. Now, if we want to implement all of the classifier algorithms and if you want to do processing on top of all of these files, then it would consume a lot of time, right? So what I'll do is I'll just take a subset of this. So from the 12,500 positive reviews, I'll just select the first 1,000 positive reviews, and similarly from the 12,500 negative reviews, I'll just select the first 1,000 negative reviews and I'll store them into the same datasets. So now files underscore POS has the first 1,000 positive reviews and files underscore NEG has the first 1,000 negative reviews. I'll click on run. Right. So this is done. Just to verify, let me again have a glance at the length of files POS and files NEG. So we see that there are 1,000 and 1,000. Right. So there are 1,000 positive reviews and 1,000 negative reviews. Now it's time to pre-process all of these reviews. Right. So I'll start off by creating two empty lists over here. So first empty list is all words and second empty list is documents, and I'll import stop words from nltk.corpus. So my first task in pre-processing would be to remove all of the stop words. So I'll just set over here list set stop words dot words, and I will get the list of all of the stop words in English, and I will store all of those stop words in this object stop underscore words. Right. Now this is done, and what I actually want now is bag of words or bag of adjectives, because adjectives are a better way to understand the sentiment of a review, right? So let's say there are some adjectives such as great, good, or bad, right? These are all of the words, or adjectives are the main words which tell us about the sentiment of a review. And that is why I would want only the adjectives from the entire review. So now during POS tagging, each of these parts of speech have a different letter assigned to them, such as adjective is denoted with J, adverb is denoted with R, and verb is denoted with V. So since I want only the adjectives, I will set over here that the allowed word types are only J, or in other words, I want only the adverbs from all of the parts of speech. Right, so this is the initial pre-processing. Now I'll start this for loop, and it goes through all of the reviews in files underscore POS. So for P in files underscore POS, it starts with first review and goes on in the 1000 positive reviews. So now I have this empty documents list over here, and using this, what I'll do is I'll actually create a list of tuples where the first element of each tuple is a review and the second element is the label of the review, right? So P, it is basically for P in files underscore POS. So over here, if we start in the for loop, then it will have the first review, and over here POS basically means that this review is positive. Again, this will iterate, and then we will have the second review, and again the second review is also positive. Then we'll have the third review, and again we'll set the label which is positive again, right? So this will go on inside this loop. Now once we create this list of tuples, we also have to remove the punctuations present in the reviews. So I'll pass in P over here, and this is the syntax to remove all of the punctuations, right? And this is how I'll remove all of the punctuations. So now I've removed the punctuations. Now it's time to also tokenize my words. So tokenizing words is very important. So each individual word or each individual element present in all of these reviews would be tokenized. And for that purpose, I would have to use the word underscore tokenize function, and I will pass in this cleaned object into this. So this cleaned object is that object which does not have any punctuations. I'll pass it inside the word underscore tokenize. Now, once it is tokenized, I will store the result in tokenized. Right. So now we have the tokenized result, and we would have to remove all of the stop words from all of these tokens. So let's understand this over here. So W for W in tokenized, if not W in stop words. So this basically means that if the token is not present in stop words, then go ahead and store it into stopped. And this loop will continue, and we'll get only those tokens which are not present in stop words, right? So we have successfully removed all of the stop words, and I will pass this object inside NLTK.pause tag function. With the help of this, I can do the POS tagging of all of the tokens, right? So I have all of my tokens with me, and I'll just do the POS tagging or the parts of speech tagging for all of the individual tokens, and I'll store it into POS. And this is where I have all of the tokens associated with a parts of speech tag. Now, as I already told you earlier, from all of these parts of speech, I would want only adjectives. I do not want all of the parts of speech. So over here inside this loop, what I'll do is I will just select only those tokens which are present in allowed word types, or in other words, I am extracting only those tokens which are adjectives, and I will store all of them in all words, right? So now all words has all of the positive adjectives present in it, right? So we have stored all of the positive adjectives into all words, and we'd have to do the same thing for all of the negative reviews. So this time I'll start the loop for all of the negative reviews. So this will go like this: for P in files underscore neg, and over here I am again creating a list of tuples where the first element of each tuple is the review, but this time this is the negative review, right? So this is the negative review which is present in files underscore neg, and I will also associate a label with it which is neg this time, right? Since over here this is a negative review, I have the review over here and the label is neg, which tells us that this is a negative review. Now this is done. I would also have to remove all of the punctuations present inside this negative review. So I'll just type in re.sub, and this is how I can remove the negative punctuations. And then I'll go ahead and tokenize the words. So I'll pass in this cleaned object into word tokenize, and we'll store all of the tokens in tokenized. Now it's time to remove the stop words. So W for W in tokenized, if not W in stop words. This means that this loop will go through all of the stop words, and if the token is not present in stop words, only then that token would be stored in the stopped object. Or in other words, I would want only those tokens which are not present in the stop words object. So I have removed the stop words. Now it's time for parts of speech stacking. So I'll pass this stopped object into NLTK.pos tag, and this helps me to do parts of speech tagging to all of the tokens. Now for sentiment analysis, I would require only the adjectives and not all the parts of speech. So again, I'll start this for loop, and this for loop will go through all the tokens present in NEG, and it will extract only the negative adjectives and it will append to all words. So initially in the above for loop, we had all of the positive adjectives, and with the help of the below for loop, we have all of the negative adjectives appended to all words. So now this all words is a combination of all of the positive adjectives and all of the negative adjectives. Right, so now we have our bag of words or bag of adjectives with us. So now I'll go ahead and create a frequency distribution for all of these adjectives. And for that purpose, I'd have to use NLTK.freqdist, and I'll pass in the all words object inside this. I'll click on run, and this is the frequency distribution. So see that the adjective good occurs 1157 times, bad occurs 743 times, great occurs 660 times, much occurs 482 times, and so on. Now, let me also visualize this graphically. So I'll import matplotlib, and I'll just make a simple line plot for this. So this is our line plot, and we see that good is the adjective which occurs most number of times over here, and it occurs around 1157 times. Now out of all of these adjectives, I would want the 1000 most frequently occurring adjectives. Right, so I'll just extract the 1000 most frequently occurring adjectives. So I'll type in all words.keys, and I'll extract the 1000 or the first 1000 adjectives, and I'll store it into word features. Right, so these are the 1000 most frequently occurring adjectives over here. So now we'd actually have to create a tuple where the first element is a dictionary and the second element is the label positive or negative. So to create the dictionary of features, we'll actually use this user-defined function. So what we'll do is we are supposed to create a dictionary of features for each review present in the list document, right? So for each review present, we will create a dictionary of features. Now in this dictionary, the keys are all of the words in word features, and the values of each key are either true or false, which basically tell us whether that feature appears in the review or not. And it basically looks something like this. So we have a tuple. The first element of the tuple is a dictionary, and in that dictionary the key basically comprises of all of the adjectives, and the value is basically true or false, which tells us if the adjective is present in the review or not. And then the second element of the tuple is basically POS or NEG, which would tell us whether the review is positive or negative. And we are doing this because we'd want to find out whether this particular review is positive or negative. So this user-defined function which you see, this helps us to do something like that. Now out of that, we will create this feature set. So this feature set is nothing but our tuple, where the first element is a dictionary and the second element is basically the label, which is POS or NEG. And then I'll go ahead and shuffle these feature sets, and I will divide these feature sets into training and testing data. So the training data would comprise of 800 reviews and the testing data would comprise of 200 reviews. So the first 800 features go into the training set, the last 200 features go into the testing set. I'll click on run. Now let me have a glance at the first feature set, right? So this is our dictionary over here, which is the first element. So what we see is this. So this is the adjective, and this false basically tells us that this adjective is not present in the review. So let's actually find for true, right? True, and it is BR. So this tells us that BR is present in the review. Let us find for some other true value, right? Better is present in this review. Let me also find some other true label. Let's see, where do we get a true label down? Right, so over here we have mediocre. So mediocre is present in this review. So wherever we have false, it basically means that those adjectives are not present in the review, and wherever we have true, it means that those adjectives are present in the review. Now let me go totally down and let me see what is the label. So this is pause, right? So combining all of the adjectives which are present in the review When combined, they give us the positive label. And this is the training set. Now what I want is, I would build a couple of classifiers on top of this training set, and once the learning is done, I will try to predict the values on top of the test set and see whether the prediction is correct or wrong. So the training will be done on this training set. It learns all of these features, it learns the labels. Once that is done, I'll predict the values on top of the test set. So I'll start off by implementing the naive Bayes classifier. So I'll just type in NLTK.naive Bayes classifier and I will train it on top of the training set, and I will check for its accuracy on top of the test set. And I'll just print it out. And after that, I would also want to show the 15 most informative features from this classifier. So I'll click on run. So we see that we get an accuracy of 75.5% when we build this model on top of the training set. And these are the most informative features, right? So powerful, serial, cheap, unique. So these are the 15 most informative features when we build this classifier. And on the right side, what you see over here is the ratio of positive to negative is 11.3 to 1.2 for this adjective. This means that the word powerful is 11.3 times more likely to occur in a positive review than a negative review. And this is for serial, and this is negative to positive. This means that the adjective serial is 8.1 times more likely to occur in a negative review than a positive review. Again, we have cheap. So over here, this word cheap is 6.5 times more likely to occur in a negative review than a positive review. And again, let's take this superb adjective over here. So this means that the word superb is 4.9 times more likely to occur in a positive review than a negative review. So we have implemented the naive Bayes classifier on top of the training set, and we've got an accuracy of 75.5%. Now we'll go ahead and implement some other classifiers. So we'll start with multinomial naive Bayes, then we'll implement binomial naive Bayes, then logistic regression. After that, SGD classifier, which is basically stochastic gradient descent, and finally we'll also implement SVC, which is support vector classifier. So let me import all of these packages first. Right, so we have imported all of these packages. Now we'll implement the first classifier, which is multinomial NB. So I'll just create an instance of this, and I'll store the instance in MNB CLF, and I will train this classifier on top of the train set, and I'll store it in MNB CLS. Now since I've built the model on top of the train set, I can go ahead and predict the values on top of the test set. So again, I'll just type in nltk.classify.accuracy. So I want the accuracy where my predicted results are stored in MNB_CSL and my actual values are in the test set, which is basically the testing set. Let me print this out. So we have built the multinomial naive Bayes classifier and we've got an accuracy of 77.5%. Now we'll build the binomial naive Bayes classifier. So I'll just create an instance of binomial naive Bayes and store it in BNB_CLF, and I will fit this model on top of the train set and store the result in BNB_CSL. Now again, since I fit the model on top of the train set, I can go ahead and predict the values on top of the test set. So I'll use nltk.classify.accuracy, and over here this takes in two parameters. First parameter is basically the object which contains all of the predicted values, which is BNB_CLS, and this is my test set which comprises of the actual values. So let me click on run. And this time I get an accuracy of 75% with the Bernoulli naive Bayes. Now I'll implement the logistic regression algorithm. So I'll create an instance of it and I'll name that instance to be log_reg_CLF, and I'll fit the model on top of the training set again, and I'll store the result in log_CLS. Similarly, I'll get the accuracy by predicting the values on top of the test set. So with the logistic regression algorithm, I get an accuracy of 72%. Now we've got two more classifiers left. So this time we're going to implement the SGD classifier, which is the stochastic gradient descent classifier, and I'll name the instance of this to be SGD_CLF, and I'll fit the model on top of the train set and store it in SGD_CLS, and I will predict the values on top of the test set. I'll click on run. Right. So with the stochastic gradient descent classifier, we get an accuracy of 68%. So you see that the accuracy keeps on decreasing over here, right? So we started with multinomial naive Bayes, which gave us an accuracy of 77.5. Then Bernoulli naive Bayes gave us an accuracy of 75%. Logistic regression gave an accuracy of 72%. SGD gave an accuracy of 68%. Now let's see what accuracy the SVC classifier gives. So I'll click on run. So the support vector classifier gives a very, very low accuracy, which is just 49.5%. So now if I compare all of these accuracies, then I see that I get the highest accuracy with the multinomial naive based classifier, and the accuracy is 77.5%. So we can basically choose this model over all other models when we are trying to ascertain the sentiment of these words. Right? So this is how we can do sentiment analysis using the NLTK package and the scikit-learn package.
Now let's head to the quiz. So we have this sentence, this is Pada. Now what do you think? How many bigrams can be generated from this sentence? So these are the options. Think about it and write down the answer in the comment section. So guys, this brings us to the end of the session, and do subscribe to Intellipaat's YouTube channel for more such informative content.